The universe is full of enigmas that we still cannot explain. Stars that darken for no apparent reason, galaxies that seem to defy dark matter, mysterious signals coming from deep space. Each discovery answers one question but opens many more. This audiobook invites you on a 2-hour journey through the most perplexing mysteries of the cosmos, those that test the limits of physics and remind us how little we truly understand about the place we inhabit. Because the universe not only shines with light, it is also made of questions that continue to await answers. For example, did you know that stars, those bright points of light we see at night, can hide unimaginable complexities? Some of them could be denser than our minds can conceive, challenging our notions of matter and energy. Imagine an object that, although small, weighs more than several times the sun. What does this mean for our understanding of the universe? Then there is the enigma of Tabby's star, which appears to dim erratically. What causes it? Could it be an alien civilization building colossal structures around it? The mere idea challenges logic, but it shows us how little we know and how much we still have to learn. Speaking of surprises, there are galaxies that seem to lack dark matter, that mysterious substance that makes up a large part of the universe. How is it possible for them to exist without this essential component? What do these galaxies reveal about the formation and evolution of the cosmos? And we cannot forget the fast radio bursts, those mysterious signals coming from deep space. What generates them? Are they echoes of cataclysmic events or perhaps something more extraordinary? The duration of these signals is only milliseconds, but their impact on our curiosity is eternal. The Olbers paradox is equally intriguing. If there are so many stars in the universe, why does the night sky not shine with a bright, continuous light? This enigma leads us to question our perception of space and time, as well as the very origin of the universe. Moreover, Saturn presents its own mystery with its majestic rings. Are they a recent feature, or have they been there since the dawn of the planet? The controversy over their origin is a reminder that even the most familiar celestial bodies can hide secrets. On a more fundamental level, the quantum vacuum challenges us to reconsider what we understand about reality. A space that seems empty is, in fact, filled with energy fluctuations. What does this mean for our understanding of matter and the universe itself? And when we talk about mysterious objects, we cannot overlook Oumuamua, an interstellar visitor with unusual characteristics that leads us to question its origin and nature. Could it be an artifact from another civilization, or simply a natural phenomenon that we have yet to comprehend? Supersymmetric particles, hidden moons, the Planck limit, the asymmetry between matter and antimatter, ultra-powerful cosmic rays, hypervelocity stars, the enigmatic ninth planet, the Hubble limit, and the future of matter are just some of the questions that haunt us. Each of these mysteries represents an opportunity to expand our horizons and deepen our understanding of the universe. Finally, what does the future hold for us? Will more enigmas continue to arise as our technology and knowledge advance? The search for answers is an endless journey, one that invites us to explore, to question, and to marvel at the vastness of the cosmos. So as you look at the stars, remember that each point of light is a reminder of how little we know and how vast the mystery we call the universe truly is. Quark stars are a true enigma of the universe, but what exactly are they? Imagine an object so dense that a teaspoon of its material would weigh more than an entire ocean. These stars, which belong to a theoretical category, are considered even more compact than neutron stars, which are already incredibly dense. But how is it possible for them to exist, and what do they tell us about the nature of matter? To understand this, we must first remember that matter is composed of atoms, and atoms are made up of protons and neutrons. However, in the case of quark stars, neutrons break down into quarks, which are even more fundamental particles. This means that within these objects, matter is organized in a way that challenges our current understanding. What happens when quarks group together in such an extreme manner? The idea of quark stars arises from theories that attempt to explain the extreme conditions present in the universe. Think of supernova explosions where matter is compressed in such a way that it gives rise to extremely dense objects. The question is, could there be a star that after this compression evolves even further, becoming a conglomerate of quarks? We do not have the answer yet, but scientists are constantly searching for evidence that could confirm or refute this hypothesis. The study of quark stars is not only fascinating but could also provide answers to some of the deepest mysteries of physics. For example, what is gravity like under these extreme conditions? How does matter behave in an environment where fundamental forces seem to manifest differently? These questions are not just theoretical. They have profound implications for how we understand the universe. As we explore this topic, another intriguing question arises. Could we ever observe a quark star? The answer is complex. Despite the tremendous advancements in technology and astrophysics, detecting these objects remains a monumental challenge. However, astronomers have identified certain phenomena that could be indicative of their existence. For example, gamma-ray bursts have been recorded coming from regions of space where these mysterious stars are suspected to be located. In this sense, a world of possibilities opens up. If we manage to confirm the existence of quark stars, how would it change our view of the cosmos? Perhaps new physical principles would be revealed, or maybe discovering them would help us better understand dark matter and dark energy, two of the most enigmatic components of the universe. Moreover, the existence of these stars could lead us to rethink the formation and evolution of celestial bodies. Could they influence the dynamics of galaxies in ways we have yet to imagine? Quark stars have the potential to rewrite our textbooks on the universe. Furthermore, this mystery also has philosophical implications. The idea that there is a form of matter we have yet to see raises questions about the limits of our knowledge. What other surprises does the universe hold for us? Are we prepared to understand what we do not yet comprehend? And what about the relationship between quark stars and other theories of modern physics? For instance, string theory and quantum gravity could offer new perspectives on how these stars function. Could it be that by studying these celestial monsters we come closer to a unified model of physics? Advancements in telescope and observatory technology also play a crucial role. Each new discovery in the field of astronomy brings us a little closer to solving this mystery. Perhaps soon we will have the opportunity to directly observe quark stars, or at least their effects on the surrounding space. As we continue to investigate, it is essential to remember that each answer we find may lead to new questions. Science is a dynamic process, and the mystery of quark stars is a reminder that the universe remains a place full of surprises. Who knows what other secrets lie hidden in the darkness of space, waiting to be discovered? Ultimately, the quest for answers about quark stars shows us that, although we sometimes feel small in the vastness of the cosmos, our curiosity and desire to understand are what define us as human beings. Every question we ask about our universe is a step forward in our journey toward knowledge. What will be the next mystery we solve? If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. What causes a star to dim so irregularly? This unsettling question has kept astronomers awake for entire nights, and the object in question is Tabby's star, a phenomenon that has unleashed a torrent of theories and speculations. Located in the constellation of Cygnus, this star has exhibited enigmatic behavior that has turned it into a true cosmic puzzle. But what makes it so special? To understand the mystery behind Tabby's star, we must first consider how stars behave in general. Normally, stars shine steadily and their light can be observed over time. However, Tabby's star behaves in a way that defies this norm. Its light flickers and dims erratically, leading scientists to wonder what could be causing these changes. One of the most intriguing theories suggests that there could be a massive alien structure orbiting the star, like a megastructure built by an advanced civilization. The idea sounds like something out of a science fiction novel, but observational data has led some to consider this possibility. Could it be that we are witnessing a sign of intelligent life beyond our planet? However, that is not the only explanation. Other scientists have proposed that the dimming could be the result of a group of comets passing near the star, throwing off dust and particles that block its light. This theory suggests that instead of an alien phenomenon, we might be observing a natural occurrence. But can comets really cause such dramatic and prolonged dimming? Furthermore, some believe that the phenomenon could be related to the star's own evolution. Stars have life cycles, and at certain stages they can experience changes in their brightness. But can a star really change so abruptly and without warning? The nature of the universe is astonishing, and it often reminds us that there is much we still do not understand. The irregularity in the brightness of Tabby's star has been so pronounced that some researchers have dubbed it the most mysterious star in the universe. But what does this mean for our understanding of the cosmos? Each time we encounter a mystery like this, a door opens to new questions and explorations. Science advances through curiosity, and the desire to unravel the unknown is what drives astronomers to look beyond. The data obtained from Tabby's star has been gathered through various telescopes, allowing scientists to study its behavior in greater detail. As studies continue, each new finding raises new questions. Could there be other similar phenomena in the universe that we have yet to discover? How many more stars might be hiding secrets that challenge our understanding? Meanwhile, interest in Tabby's star has not waned. The scientific community is divided between those who believe the phenomenon can be explained by natural causes and those who cling to the idea that there could be something more, something that forces us to rethink what we know about life in the universe. Are we really alone in this vast cosmos? In recent years, research on Tabby's star has spurred the development of new technologies and observation methods. Human curiosity about understanding the unknown has led to the creation of more advanced telescopes and collaboration among scientists from different disciplines. What other secrets might be revealed in the future thanks to these advancements? As we continue to explore the universe, the case of Tabby's star highlights the importance of keeping an open mind. Science is a constantly evolving process, and what seems like a mystery today may become knowledge tomorrow. Each question that arises pushes us forward toward a better understanding of our place in the cosmos. Ultimately, the mystery of Tabby's star is a reminder that, while we have made significant strides in our understanding of the universe, there are still many enigmas waiting to be solved. The quest for answers is endless, and each discovery brings us one step closer to unveiling the secrets of space. What other mysteries does infinity hold for us? Are you ready to keep exploring? What if I told you that there are galaxies that seem to lack the dark matter that everyone expected to find? This is a mystery that has left many astronomers scratching their heads and rethinking what they thought they knew about the universe. Dark matter, that mysterious substance that makes up most of the cosmos, has been fundamental in explaining how galaxies form and evolve. However, there are some galaxies that seem to challenge us, showing an absence of this elusive matter. But why is dark matter so crucial? Imagine the universe as a giant puzzle. Normal matter, the kind we can see and touch, represents only a small part of the pieces. Dark matter, on the other hand, is like those missing pieces. Without them, the puzzle doesn't look complete. Without dark matter, galaxies wouldn't have enough gravity to hold themselves together and would disintegrate into a torrent of stars and gas. Now let's talk about the galaxies that don't seem to follow this rule. Several have been discovered that appear to function without this dark matter. How is this possible? Do we need to rewrite the textbooks? One fascinating example is the galaxy NGC 2094, which has left scientists perplexed. Despite its movements and structure, no evidence of dark matter has been found in it. What does this mean for our understanding of the universe? Some scientists suggest that these galaxies may have formed in a different environment, where dark matter simply wasn't part of the creation process. Imagine a galaxy that has evolved in a place where the conditions were so unique that dark matter couldn't influence its formation. This opens up a range of questions. Are there different types of galaxies that don't depend on dark matter? Could there be an alternative universe where gravity works differently? Astronomers have proposed various theories to explain these anomalies. One suggests that perhaps dark matter exists but doesn't behave as we think. Maybe it has different properties or interactions that we haven't discovered yet. If this is true, we could be on the verge of making a monumental breakthrough in physics. But what about the galaxies that do have dark matter? Why do some seem to be the exception to the rule? Scientists are conducting extensive research using telescopes and advanced technology to try to detect this mysterious matter. Imagine the excitement of an astronomer who, looking through their telescope, might discover a new galaxy that challenges everything we know. Despite technological advances, dark matter remains one of the great unknowns of the universe. It is estimated to constitute about 95% of the total mass of the cosmos. This means that, although we cannot see or touch it, its influence is undeniable and critical to the structure of the universe. And here comes another intriguing question. If dark matter is so predominant, why can't we detect it? The answer may lie in the fact that it doesn't interact with light or matter in the same way that normal matter does. This invisibility leaves us in a constant search, trying to unravel its secrets. The absence of dark matter in some galaxies could also mean that we need to revisit our theories about gravity. Einstein's theory of relativity has been our guide for decades. But if these galaxies operate differently, could there be something more we need to understand? The possibility that new forces or interactions are at play is exciting and could open the door to a new chapter in physics. As scientists continue to investigate, curiosity becomes the driving force behind the advancement of knowledge. Each new discovery about these galaxies without dark matter could be the key to understanding not only the past of the universe but also its future. How will these galaxies develop over time? Are they destined to collapse or evolve in ways we cannot yet imagine? Exploring these mysteries not only helps us better understand the cosmos, but also invites us to reflect on our place within it. If the universe is stranger than we think, what other surprises await us? The search for answers becomes an exciting journey, where each discovery can bring us one step closer to unraveling the secrets that the universe holds. Ultimately, galaxies without dark matter serve as a reminder that, even in science, there are more questions than answers. They challenge us to think beyond what we know and to consider that perhaps the rules of the universe are more flexible than we imagine. The quest for truth continues, and who knows, in the vast ocean of space we might find pieces of the puzzle that change our perspective forever. Fast radio bursts, known as FRBs, are one of the most intriguing and perplexing phenomena in the universe. What exactly are they? These are radio signals that last only milliseconds, but in that brief moment, they release more energy than our sun emits in an entire year. How can something so brief be so powerful? Even the most experienced astronomers have been astonished by these mysterious bursts. Since their discovery in 2007, FRBs have captured the attention of scientists around the world, but where do they come from? Thousands of these signals have been detected, and each seems to have its own story. Some are recurrent, suggesting they might have a closer origin or perhaps a cycle of activity. Others, however, appear in isolation, leaving researchers with more questions than answers. The first time an FRB was recorded was a revealing moment. Astronomers realized there was something in the cosmos they could not explain. Could they be signals from advanced civilizations? The idea that these bursts might actually be a form of extraterrestrial communication has fascinated many. However, most scientists are more cautious, suggesting it is more likely that these signals come from extreme astrophysical phenomena such as neutron star mergers or supernova explosions. But how can we be so sure they are not signals of intelligent life? As researchers delve deeper into the study of FRBs, they have found that most current theories are based on natural processes. The energy they emit is too powerful to be generated by known technologies. Nevertheless, the possibility that there is something beyond our understanding is always present, challenging our imagination. One of the most puzzling features of FRBs is their origin, which has yet to be precisely located. Why do some signals seem to come from distant galaxies while others appear to be more local? Astronomers have embarked on an intense search using telescopes around the world to trace their provenance. But despite their efforts, many of these signals remain a mystery. FRBs also raise questions about the nature of space itself. The way these signals travel through the universe may reveal information about the properties of the interstellar medium. What do they tell us about dark matter and dark energy, which make up most of our cosmos? As scientists study these bursts more, they are increasingly convinced that they may hold crucial clues to understanding the structure of the universe. It is interesting to note that despite their brevity, FRBs showcase the power of observation and technology. The ability to detect and analyze these fleeting signals is a testament to human ingenuity. How many more mysteries await us in the vast cosmos? Each detection of an FRB becomes an invitation to explore beyond the limits of our current knowledge. Theories about their origin are varied. Some suggest they could be related to supermassive black holes, while others postulate that they might result from collisions between neutron stars. However, each new hypothesis brings more questions. How do these phenomena relate to the evolution of galaxies? What role do they play in the history of the universe? As astronomers continue their search, FRBs maintain their status as one of the great enigmas of the cosmos. Each new detected signal is a reminder that despite advances in science, there is still much we do not understand. How many more of these mysterious bursts exist in the vast universe? Human curiosity drives us to keep exploring, seeking answers in a place where silence is often deafening. The exploration of these bursts leads us to reflect on our own existence in the universe. If there are such powerful and enigmatic phenomena, what else could be out there? In a universe full of mysteries, each answer generates new questions, and each discovery brings us a little closer to understanding the vast and complex tapestry of the cosmos. So, as we continue to observe the sky, each fast radio burst is an opportunity to marvel. It invites us to keep searching, to question, and to explore. What will the future hold in our quest for answers about the universe? The possibilities are as infinite as the cosmos itself. Undoubtedly, FRBs are just one of many gateways to a universe full of mysteries waiting to be revealed. The night sky offers us an impressive spectacle. However, there is something that continues to intrigue us. Why, with so many stars in the universe, are we not surrounded by a bright light? This enigma is known as the Olbers paradox. But what does this really mean, and why is it so perplexing? First, let's consider the vastness of the cosmos. There are billions of stars in our galaxy, and our galaxy is just one of the hundreds of billions that exist. With so many stars emitting light, one might think that the sky should shine brightly, but that is not what we see. So where is all that light? One possible answer relates to the expansion of the universe. Since the Big Bang, the cosmos has been constantly expanding, which means that stars far from us are moving away. This causes a phenomenon called redshift, which makes the light from those stars shift to longer wavelengths, becoming less visible. Does this mean there are more stars than we can see? Undoubtedly, but that does not completely solve the mystery. Additionally, the universe has a finite age. Not all stars have existed since the beginning of time. There are stars that have been born and died before the light from others could reach us. This raises a fascinating question. How many stars have existed and no longer shine in the vast universe? Another theory suggests that the light from stars can be absorbed in interstellar space. This could be due to the presence of dust and gas that scatter and absorb light, preventing it from reaching our eyes. But is this enough to explain the darkness of the sky? It seems not, as even with enough material in space, we should still see more light than we actually observe. Delving deeper into the paradox, we must consider that the universe is not static. New stars are constantly forming, while others fade away. This cycle of birth and death of stars also plays a crucial role in the amount of light we can perceive. But what about the stars located in more distant regions? Shouldn't they contribute to the light we see from Earth? The phenomenon can also be explained through relativity. According to this theory, light traveling through space does not always reach us in the same way. The curvature of space-time can affect how we perceive the light from distant stars. Therefore, light that might have been visible in a static universe becomes more difficult to detect in an expanding one. The Olbers paradox also leads us to question our own existence. If the universe is so vast and full of stars, why are we so insignificant in comparison? This reflection invites us to contemplate the place we occupy in the cosmos and what it truly means to be human in the midst of such an impressive and sometimes perplexing universe. Every answer we find to this paradox only generates more questions. How did the first stars form? What other factors might be influencing the light we perceive? Science continues to explore these issues, seeking to unravel the mysteries that lie in the darkness of the sky. The Olbers paradox is not only an astronomical puzzle, but also invites philosophical reflection. It makes us question our understanding of the universe and of ourselves. As we continue to seek answers, we may discover that some questions are as valuable as the answers themselves. Ultimately, the Olbers paradox is a reminder that, although the universe may seem dark and empty, there is a rich history and complexity yet to be explored. Every star, every galaxy, and every corner of the cosmos has its own mystery, and perhaps, in the pursuit of those secrets, we will discover not only more about the universe, but also about our own existence. The fascination with Saturn and its rings has captured the imagination of humanity for centuries. But have you ever wondered how those majestic rings actually formed? The story of Saturn is more than just a simple astronomical account. It is an enigma that invites us to explore the secrets of time and space. Many scientists have wondered whether these rings have been a feature of the planet since its birth, or if they are a relatively new phenomenon in the history of the solar system. When we look at Saturn, what we see are bright rings that seem to float in space, but what lies behind that beauty? Some astronomers suggest that these rings could have formed from moons that once orbited the planet. Imagine a satellite getting too close to Saturn and, due to the intense gravity, breaking apart into thousands of pieces, creating an impressive spectacle in the sky. However, this scenario raises more questions than answers. How much time has passed since this event occurred? On the other hand, some believe that Saturn's rings are much older than we think. Could they be remnants of a time when the solar system was a chaotic place, filled with colliding celestial bodies? The theories about the age of the rings suggest that they may have existed for billions of years, possibly since the formation of the planet. This leads us to wonder, what do these rings tell us about the history of the solar system as a whole? Recent observations of Saturn's moons have revealed even more complexities. Some of them, like Enceladus, show signs of geological activity and could be contributing to the material of the rings. Could it be that the moons are not just satellites, but also part of a continuous cycle of creation and destruction? The idea that the rings are fed by the moons prompts us to rethink our understanding of how planetary systems work. As scientists study the rings with advanced technology, they have discovered that they are primarily composed of ice and rock particles. But why are they so well defined and not diffusing into space? The answer may lie in the dynamics of gravity. The rings are in a delicate balance where Saturn's gravity keeps the particles together while centrifugal force keeps them in motion. This phenomenon becomes a true cosmic ballet that challenges our intuitions about physics. The rings are not permanent. In fact, there are theories suggesting that they could disappear in less than 100 million years. This leads us to wonder, how will this affect Saturn and its moons in the future? The impending disappearance of the rings creates a sense of urgency in the need to study this planetary system. Are we in time to uncover all its secrets before they crumble into history? The controversy over the age of Saturn's rings also extends to their appearance. Some researchers suggest that the rings are much darker than they appear. Could it be that sunlight is deceiving us and what we see is only a fraction of the truth? This dilemma regarding the brightness of the rings serves as a reminder that human perception can be limited when it comes to astronomical phenomena. Moreover, the composition of the rings is constantly changing. Dust and ice particles collide with each other, creating new structures and altering the way we see these rings. What new surprises could these collisions hold? Each observation brings with it the possibility of discovering something completely unexpected, keeping scientists in a state of constant alertness. The influence of Saturn on its environment is also a fascinating aspect of its study. Winds and currents in space affect the dynamics of the rings and the moons. How do these elements interact with Saturn's gravity? This cosmic dance between the forces of space is a reminder that our universe is in constant motion, always changing and evolving. The relationship between Saturn and its rings also leads us to reflect on our own existence. How do the systems we live in form? What role do interactions between celestial bodies play in creating a suitable environment for life? The story of Saturn is ultimately a story of connection and transformation. As we delve deeper into the mystery of Saturn and its rings, we realize that each answer generates new questions. What else lies hidden in the dark corners of our solar system? Human curiosity drives us to seek answers, to explore the unknown, and to question what we take for granted. So the next time you look at Saturn in the sky, remember that its beauty is just the surface of a deep mystery. Each ring, each moon, each ice particle tells a story that invites us to keep exploring. Are we ready to unravel the secrets that the cosmos has to offer? The quest for knowledge never ends, and Saturn is just one of the many mysteries waiting to be discovered. Quantum vacuum is a concept that challenges our understanding of reality as we know it. But what exactly is it? In the world of quantum physics, we might think of the vacuum as a completely empty space, with nothing in it. However, this could not be further from the truth. In the quantum vacuum, particles are constantly emerging and disappearing, creating a sea of activity that we cannot see with the naked eye. Isn't it surprising to think that in what seems to be an absolute void, there is actually a constant dance of energy? So how is it possible for something to arise from nothing? The answer lies in the laws of quantum mechanics, which allow particles to appear and disappear in short periods of time. This is known as quantum fluctuations. Imagine an ocean where waves rise and fade in an instant. Each wave represents a particle that appears and disappears. But what does this mean for our understanding of the universe? How do these fluctuations affect the matter and energy that surround us? You might think these fluctuations are insignificant, but in reality, they play a crucial role in the creation of the cosmos. It has been speculated that the quantum vacuum could be responsible for the formation of particles in the early universe just after the Big Bang. Can you imagine a universe where, from nothing, all the particles that make up the matter and energy we know today emerged? It's a fascinating thought, isn't it? Moreover, the quantum vacuum has implications for the energy of the future. Some theories suggest that we could harness this vacuum energy to obtain unlimited energy. What if we could use these fluctuations to power our cities? It would be a radical change in our way of living. But is this really possible? The answer remains a mystery. Although the quantum vacuum seems to be an abstract concept, it has very real applications. Advances in quantum technology, such as quantum computing, depend on these principles. Have you ever wondered how scientists manage to build computers that can process information at unimaginable speeds? The key lies in understanding the properties of the quantum vacuum and how we can manipulate them. However, the quantum vacuum also raises deeper questions about the nature of reality. What does empty really mean? If a space can be filled with energy and fluctuations, does it mean that the vacuum is itself a form of matter? Such questions lead us to reflect on the concept of existence. Do we really know what the vacuum is, or is it just an illusion created by our limited perception? As we delve deeper into the quantum vacuum, we find that it also relates to gravity and the structure of space-time. How are these fundamental concepts intertwined? Some scientists suggest that the quantum vacuum could be linked to gravity through string theory, which attempts to unify all the forces of nature. But will we ever fully understand this relationship? Another intriguing aspect of the quantum vacuum is its connection to dark energy, a mysterious force that seems to be accelerating the expansion of the universe. Could the quantum vacuum be the key to understanding this phenomenon? Dark energy accounts for about 70% of the total content of the universe, and its nature remains one of the greatest puzzles in cosmology. What role does the vacuum play in this cosmic expansion? The quantum vacuum also leads us to question the nature of reality itself. If everything we see and touch is in constant change due to quantum fluctuations, can we trust our senses? Is the universe a stranger and more complex place than we can imagine? These questions invite us to explore the limits of our understanding and open our minds to new possibilities. Additionally, the quantum vacuum has philosophical implications. What does it mean to be? Do realities exist beyond what we can observe? These questions have fascinated thinkers throughout history, and the study of the quantum vacuum could provide answers to some of them. In the end, the vacuum is not just an empty space, but a field full of potential and mystery. In summary, the quantum vacuum is a concept that challenges our understanding of reality and invites us to explore profound questions about the universe. From its role in the creation of particles to its relationship with dark energy, the quantum vacuum is at the heart of many mysteries that remain to be solved. What discoveries await us in the future? Only time will tell, but what is certain is that the quantum vacuum will continue to be an area of fascination and research for scientists and philosophers alike. The universe constantly surprises us, and one of the most fascinating enigmas we have recently discovered is Oumuamua, an interstellar object that has left scientists and astronomers alike perplexed. But what exactly is Oumuamua? It is an object that passed near our solar system in 2017, and its passage was so peculiar that it triggered a wave of curiosity in the scientific community. What makes it so special? To begin with, Oumuamua is the first known object that comes from outside our solar system. Until that moment, we had only observed asteroids and comets that formed in our own cosmic neighborhood. However, upon observing Oumuamua, we found ourselves facing something completely different, a visitor that arrived from an unknown place, leading us to wonder, where did it really come from? As scientists observed its trajectory, they noticed that Oumuamua did not behave like a typical asteroid. Its shape is elongated, almost like a cigar, and its brightness varied strangely, suggesting that it rotates on its own axis at an unusual speed. What could cause such strange behavior? Some theories suggest it could be a fragment of a planet or a moon that was ejected from its own stellar system, but what kind of world could have created it? The curiosity doesn't stop there. Some researchers have even suggested that Oumuamua could be a spacecraft of extraterrestrial origin. This idea may sound far-fetched, but what would it imply if it were indeed a probe sent by an advanced civilization? Imagine the possibilities. What kind of technology might they have? Why would they visit us? However, most scientists remain skeptical. As more observations were made, it became clear that Oumuamua showed no signs of technology. There were no lights or structures suggesting it was an artifact created by intelligent beings. So why do we keep talking about it? The answer is simple. Oumuamua raises fundamental questions about the nature of the universe and how celestial bodies form. The fact that it is an interstellar object leads us to reflect on how many other Oumuamua might be traveling in the vast space invisible to us. Could there be more visitors like it in our galactic neighborhood? What secrets might they bring with them? The exploration of these objects could open new doors to understanding how stars and planets form in other solar systems. As Oumuamua moved away from us, astronomers realized there was a limited window for its study. This has led to intense debate about how we should search for and analyze future interstellar objects. Are we prepared to discover more surprises like Oumuamua? The intriguing nature of Oumuamua can also be seen in its composition. Some studies suggest it might be made of metallic materials, while others point to the possibility that it could contain ice. What implications would this have for our understanding of celestial bodies in deep space? If Oumuamua is indeed a fragment of an asteroid or a comet, could it be an indication that other similar worlds exist in the universe that we have yet to discover? The search for objects like Oumuamua also leads us to question our current theories about the formation of the solar system. Every discovery we make forces us to reevaluate what we think we know. Are we really understanding the process of celestial body formation? Oumuamua could be the key to unlocking new theories that explain how these objects are created in the cosmos. Science is advancing rapidly, but Oumuamua reminds us that there is still much to discover. Every day presents new challenges and mysteries. Space exploration is on the rise, and the possibility of finding more interstellar objects like Oumuamua in the future is exciting. Who knows what other secrets the universe holds for us? Ultimately, Oumuamua is not just an object, it is a symbol of our innate curiosity. It reminds us that the universe is vast and enigmatic, full of surprises waiting for us. The quest for answers to the mysteries of Oumuamua and other celestial bodies unites us in our desire to understand more about our place in the cosmos. The story of Oumuamua is just the beginning of a cosmic adventure that invites us to look toward the stars and question everything we think we know. Supersymmetric particles are one of the most intriguing concepts in the world of theoretical physics. What exactly are they? In simple terms, they are particles that, according to certain theories, could exist in the universe and have a special relationship with the particles we already know. But why are they so important? The answer is that they could be the key to solving many of the enigmas that the cosmos still presents to us. Think about this. If every particle we know has a supersymmetric counterpart, that would mean the universe is a much more complex place than we imagine. What if I told you that these particles could help explain dark matter, that mysterious substance that seems to make up a large part of the universe but that we have never been able to see? Imagine being able to unravel the secrets of dark matter through these yet undetected particles. Moreover, supersymmetric particles could provide answers to the famous question of the Standard Model of particle physics. This model has been very successful in describing how fundamental particles interact, but it also has its limitations. For example, it cannot explain why gravity is so weak compared to the other three fundamental forces. Supersymmetric particles could offer a solution to this dilemma, uniting the forces in a single coherent theory. Now, why have we not yet found evidence of these particles? The answer to this question is fascinating. The most advanced experiments, such as those conducted at the Large Hadron Collider, have actively searched for these particles, but so far they have not succeeded. This leads us to wonder, are we looking in the right place? Or do we perhaps need new technologies to discover what eludes us? The search for supersymmetric particles also offers us a window to explore the concept of dark energy. This strange form of energy seems to be driving the acceleration of the universe's expansion. Theories that include supersymmetry could provide a framework for understanding how all these forces and phenomena are related, giving us a more complete picture of our cosmos. Imagining a universe where these particles exist also leads us to ask questions about life itself. If the supersymmetry model is confirmed, could there be forms of life that interact with these particles in ways we do not yet understand? Each new discovery in physics invites us to rethink what it means to be part of this vast universe. Supersymmetric particles also have implications in cosmology. By studying their possible existence, we could gain clues about the early moments of the universe and how it formed. Can you imagine being able to look back in time to the first moments of the Big Bang and understand how the forces that govern the universe were established? This is the potential that supersymmetry offers us. However, not everything is that simple. Supersymmetry is a theory, and as such it faces challenges. There are many versions of it, and not all agree on their predictions. This means that physicists must continue to work, investigate, and test these theories in the hope that one day the existence of these particles can be confirmed. Each new research effort regarding supersymmetric particles leads us into a labyrinth of possibilities, from the creation of new technologies in laboratories to international collaboration among scientists. The search for these particles is a collective effort that reflects human curiosity and our need to understand the universe. What secrets will they reveal to us in the future? One of the most intriguing questions that arises is, what if we never find evidence of these particles? Some scientists believe that would not mean the end of supersymmetry, but rather a reconfiguration of our current theories. We may have to rethink the standard model and explore new avenues of research that could lead us to even more astonishing discoveries. Supersymmetric particles, although still a mystery, are a testament to our relentless pursuit of knowledge. They show us that, although there is much we do not know, each question brings us a little closer to understanding the universe we inhabit. Are we ready for what we might find? Science advances, and with it, our ability to comprehend what surrounds us. Finally, let us reflect on the fact that science is a journey, not a destination. Each discovery, each question, each mystery we solve leads us to new uncertainties. Supersymmetric particles are just one piece of the cosmic puzzle, an invitation to keep exploring, to keep questioning, and to never lose our curiosity about the universe. The search for these particles represents our essence as human beings, the need to understand, to discover, to unravel the mysteries that surround us. In the vastness of our solar system, there is a mystery that has intrigued astronomers and space enthusiasts alike: hidden moons. What exactly are these moons, and why are they so important for our understanding of the cosmos? Imagine there are more planets in our solar system than we know. It would be astonishing, right? But could it be possible that there are satellites orbiting these yet-to-be-discovered planets? Hidden moons could be more than just simple satellites. They could be complete worlds in themselves with unique features and conditions. Have you ever wondered how it is possible that despite advances in space observation technology, we still haven't found all the moons orbiting the planets we know? What prevents us from seeing them? Perhaps they are too far away, or maybe they are so small that they escape our view. The search for these moons could radically change our perception of how a planetary system forms. Some scientists believe there are moons waiting to be discovered in the most remote regions of our solar system, beyond the orbit of Neptune. Imagine a satellite orbiting an unknown planet, a world that could have its own history and geological features. The possibility that these hidden moons harbor life, even in simple forms, is a fascinating concept. What kind of ecosystems could exist there, far from the light of the sun? Current models of planetary formation suggest that moons form from the same gas and dust disks that give rise to planets. However, if there are moons that we have yet to identify, could it be that the formation of these satellites is more complex than we think? The gravitational interaction between planets and other celestial bodies can lead to unexpected situations. Could some of these moons have been captured from other stellar systems? There are theories suggesting that our solar system could have a considerable number of hidden moons, perhaps even more than we know. For example, some researchers have proposed the existence of a dwarf planet, often referred to as Planet 9, that could be orbiting in the outskirts of our solar system. What if that planet had its own moons? Completely unknown to us, this would open a new dimension in our understanding of the solar system. In addition to the search for moons, the study of these hidden satellites could provide clues about the history of our solar system. Each moon has its own narrative, a story that could be written on its surface. What would they tell us about the past? Have they witnessed cosmic events that have shaped our current environment? Perhaps some of these moons have experienced asteroid impacts or have been affected by solar radiation in ways that could offer valuable information about the evolution of planets. However, the search for hidden moons is not limited to our solar system. As we explore other planetary systems in our galaxy, astronomers have begun to discover that many exoplanets have moons. What implications would this have for the search for life in the universe? If moons can harbor suitable conditions for life, then we might be looking in the wrong places. The search for these moons could lead us to find life in places we never would have imagined. Technology plays a crucial role in identifying hidden moons. With more powerful telescopes and space probes, scientists now have tools that allow them to explore beyond what was once possible. Could we be on the brink of a discovery that would change our understanding of the solar system forever? With each passing day, Advancements in astronomy give us hope of finding answers to questions we have yet to ask. As we advance in this search, it is also important to remember that science is constantly evolving. What we consider a mystery today could be solved in the not-so-distant future. What new discoveries await us? Human curiosity is insatiable, and the exploration of the cosmos leads us to question more and more about our place in the universe. The mystery of hidden moons invites us to reflect on the vastness of the universe and the infinity of the unknown. When we look at the sky, we do not only see stars and planets, but also the promise of discoveries that could change our way of understanding the world. Every moon we find, every satellite we discover, is another piece in the cosmic puzzle that is our solar system. The search for hidden moons is a journey, a path filled with uncertainties and wonders. It confronts us with questions that challenge our beliefs and pushes us to explore beyond the known. Ultimately, the desire to discover the unknown is what drives humans to look to the stars. Hidden moons are just a part of that vast mystery that is the universe. A reminder that there is always more to discover. So, what will the next great finding be? What secrets will hidden moons reveal to us? The answer lies in the sky, waiting to be unveiled. In this fascinating journey of exploration, each discovery opens the door to new questions. And so, the search continues, driven by curiosity and the human need to understand the cosmos we inhabit. What happens when we reach the limits of our knowledge about the universe? What lies beyond the laws of physics that we know? These are questions that lead us to explore a fascinating concept, the Planck limit. This boundary, which is at the heart of quantum physics, challenges our understanding of reality itself. But what does the Planck limit really mean, and why is it so important in our quest for answers? To begin with, let's think about the nature of space and time. At very small scales, smaller than we can imagine, the universe does not behave as we know it. In the quantum world, the rules are different. Here, the idea that something is empty becomes a misleading concept. In the quantum vacuum, energy fluctuations occur that give rise to virtual particles that appear and disappear in fractions of a second. But what happens when we try to measure these fluctuations? Are we not trying to apply the same rules we know to a completely different world? The Planck limit establishes an extreme scale where our current theories cease to be applicable. At this scale, both distance and time become fuzzy concepts. 1 Planck, which is equivalent to 10 raised to the minus 35 meters, is so tiny that it surpasses anything we can conceive. But what does this mean for us? It means that when trying to describe the universe in its most fundamental form, we face a wall of uncertainty. Could it be that behind this wall lie secrets that would completely change our understanding of the cosmos? When we talk about the Planck limit, we are also talking about quantum gravity. This is the theory that attempts to unite general relativity, which describes how gravity affects space and time, with quantum mechanics, which deals with subatomic particles. However, so far, scientists have not been able to find a way to merge these two theories into a single one that works in the regime of the Planck limit. This raises an intriguing question. Is there a whole beyond our current theories that explains how the universe works at its most fundamental level? Let's imagine that we could cross this limit. What would we discover? Some theories suggest that we could access a completely different universe, where the dimensions of time and space behave in ways we cannot imagine. Others propose that we might find a sea of constantly swirling energy, where the creation and destruction of particles occur infinitely. But how could we even begin to explore such a place? Human curiosity has led scientists to develop theories that explore what lies beyond the Planck limit. One of them is string theory, which proposes that fundamental particles are not points, but vibrating strings. These strings could exist in multiple dimensions, which could offer a solution to many of the enigmas we face today in physics. But how can we test something that exists in dimensions we cannot directly observe? Even in our quest for answers, we encounter more questions. If the universe has a Planck limit, does this mean that there is an end to everything we know, or is there an eternal cycle where the laws of physics are reinvented over and over again? Some scientists speculate that the universe could be in a state of expansion and contraction, going through infinite cycles of creation and destruction. Could it be that our own universe is just a small bubble in a much larger sea of realities? Moreover, the concept of the Planck limit has profound philosophical implications. If we reach a frontier where our theories do not apply, what does that mean for our search for truth? Are we destined to live in a state of eternal uncertainty? Some people might see this as a challenge, an invitation to keep exploring and questioning. Others might view it as a limitation, a barrier that prevents us from achieving total understanding. Science advances in cycles, and each new discovery forces us to rethink what we believe we know. Could it be that in the future we develop new tools and theories that allow us to penetrate the mystery of the Planck limit? The history of science is full of surprises, and every time we think we have reached the end, we find new doors opening. So who knows what discoveries await us on the horizon? Despite the uncertainty, the exploration of the Planck limit represents the best of our curiosity and desire to understand the universe. Every question we pose brings us a little closer to understanding reality, even though we know that the final answer may be beyond our reach. What other mysteries may be lurking in the shadows of knowledge? Ready to be discovered? As we reflect on the Planck limit and its implications, let us remember that the pursuit of knowledge is an endless journey. Every mystery we solve leads us to new ones, and every answer leaves us with more questions. Such is the nature of the universe, a constantly evolving enigma that challenges our understanding. At the end of the day, what truly matters is our ability to keep questioning, exploring, and marveling at the vastness of the unknown. Are you ready to continue this quest? What if I told you that despite the universe being filled with matter, there is something that doesn't quite fit into the puzzle? For years, scientists have been trying to understand why there is more matter than antimatter. This mystery, known as the matter-antimatter asymmetry, leads us to question the very foundations of physics and our understanding of the cosmos. But what is antimatter? Imagine a kind of mirror of the matter we know. Each particle of matter has its counterpart in the form of antimatter. For example, the electron, which has a negative charge, has a twin called the positron, which has a positive charge. In theory, when a particle of matter and its respective antimatter meet, they annihilate each other, releasing an impressive amount of energy. This is what is used in some advanced technologies, such as in space exploration. However, in the observable universe, antimatter is extremely scarce. Why? If, at the beginning of the universe, equal amounts of matter and antimatter were created, where is all that antimatter? The answer to this question is not simple and has generated countless theories. Some scientists suggest that in the early moments after the Big Bang, a slight imbalance occurred that favored matter. This imbalance in the creation of particles and antiparticles is crucial for our existence. If there had been a perfect equality, the universe would have collapsed in a massive explosion of energy, and we wouldn't be here to tell the tale. But how did this imbalance come about? Some researchers believe that particle physics may hold the key. Experiments in particle accelerators continue to shed light on this phenomenon, seeking evidence of processes that could have favored matter. The grand unification theory is another possible explanation. It suggests that, at extremely high temperatures, all the fundamental forces of nature unify. In this environment, interactions may have occurred that produced more matter than antimatter, but how can we prove this? Physicists are still working hard, and every small discovery could bring us closer to solving this enigma. Moreover, the matter-antimatter asymmetry also has implications for the nature of dark energy and dark matter. Both are essential components of the universe, but we still do not fully understand how they work. Perhaps the answer to the scarcity of antimatter is related to how these forces interact. What role does gravity play in all this? It is possible that gravity, being such a predominant force, has influenced the distribution of matter and antimatter in the universe. What if gravity not only affects the matter we see, but also the antimatter we do not see? This idea could open new avenues of research and understanding. Scientists are also exploring the possibility that there are regions in the universe where antimatter is more abundant. Could there be entire galaxies composed of antimatter? If this were true, it would open up a whole new world of exploration and discovery. The search for antimatter has become an exciting frontier of modern science. Experiments in laboratories like CERN are at the forefront of this search. By colliding particles at speeds close to the speed of light, physicists are trying to recreate the conditions of the early universe. Through these collisions, they hope to observe phenomena that could provide clues about how the universe was created and, therefore, why there is more matter than antimatter. However, every answer we find generates new questions. What would it mean for our understanding of the universe if we had access to antimatter? The applications could be revolutionary, from unlimited energy to new technologies in medicine and transportation. But, as with any great discovery, ethical and safety challenges also come into play that we should consider. As we advance in our understanding of the matter-antimatter asymmetry, it is vital to remember that we are exploring the frontiers of human knowledge. Each finding brings us closer to understanding not only the universe we live in, but also our place in it. With each theory and each experiment, we find ourselves on a journey into the unknown. Will we ever be able to uncover all the secrets that the universe has to offer? The search for antimatter is just one chapter in a book that continues to be written. Perhaps, in the not-so-distant future, the answer to this enigma will lead us to new dimensions of knowledge and understanding. So, as we gaze at the stars in the night sky, let us remember that each bright point could be a window to a universe full of surprises. The matter-antimatter asymmetry is just one of the many mysteries that invite us to keep exploring, questioning, and learning. In this quest, we are not only trying to understand the cosmos, but also ourselves. What other secrets await us in the vastness of the universe? They are yet to be discovered. Ultra-high-energy cosmic rays are one of the most enigmatic phenomena in the universe, but did you know that these rays travel through space at speeds close to the speed of light and possess more energy than we can explain? Imagine a subatomic particle striking our atmosphere with such force that it would be like a baseball colliding with a car at high speed. Where do these extraordinary particles come from? Scientists have been tracking the origin of ultra-high-energy cosmic rays for decades. Some theories suggest they could originate from supernova explosions or the remnants of collapsed stars. However, these explanations fail to account for the amount of energy they exhibit. Is it possible that there is something beyond what we know in the universe that is generating these particles? Have you ever wondered how these cosmic rays are detected? Although the particles are nearly invisible and pass through matter effortlessly, researchers have built enormous detectors on Earth to capture their effects. These devices are like large traps that patiently wait for one of these particles to strike. But what happens when they do? The answer is fascinating. A single cosmic ray can trigger a cascade of secondary particles, creating a glow that can be measured by scientists. Over the years, there have been recorded events of ultra-high energy cosmic rays that leave researchers puzzled. One of the most notable occurred in 1991 when a detector in the air over the state of Utah captured a cosmic ray that had energy equivalent to that of a projectile from a cannon. What kind of celestial phenomenon could generate such colossal energy? As we delve deeper into the study of these rays, the scientific community faces an intriguing dilemma. Despite advances in physics, we have still not been able to definitively identify their source. Some astrophysicists suggest they might be related to supermassive black holes or even colliding galaxies. However, these hypotheses still require more evidence to be confirmed. Could it be that ultra-high energy cosmic rays are connected to some aspect of the universe that we have yet to discover? Human curiosity is insatiable, and each discovery about cosmic rays raises new questions. For example, if these rays come from such distant places, what do they tell us about the evolution of the universe? Every time a cosmic ray strikes Earth, it brings with it information from beyond, a message from the cosmos that we have yet to fully learn to interpret. Moreover, the study of ultra-high energy cosmic rays is not only crucial for understanding the universe, it also has implications for our daily lives. For instance, these rays can affect electronics in satellites and other devices we depend on. Are we really prepared to protect ourselves from their effects? Some scientists are working on creating models that can predict where and when these events might occur, but uncertainty remains the norm. What would happen if we were to fully understand these phenomena? The answer could revolutionize our understanding of physics and astronomy. And there's more. Every time an ultra-high energy cosmic ray is detected, a door opens to a new world of possibilities. The search for its origin could lead us to discover new forces of nature that we have not yet considered. Are we on the brink of a new paradigm in physics? Additionally, the study of these rays raises questions about the nature of matter and energy in the universe. Could it be that these particles are an indication that there are forces we have yet to comprehend? The quest for answers to these questions is what drives research in the field of astrophysics. Ultimately, ultra-high energy cosmic rays are a window to the cosmos, a reminder that the universe is a place full of mysteries. Each discovery brings us a little closer to unraveling its secrets, and while some questions may remain unanswered for a time, curiosity and the pursuit of knowledge will continue to be our best allies in this cosmic adventure. So, the next time you look up at the night sky, remember that while you enjoy the stars, there are invisible particles racing through space, bringing with them clues about the past, present, and future of the universe. What other secrets will they reveal to us in the future? The exploration has only just begun. Hypervelocity stars are one of the most fascinating and mysterious phenomena in the vast cosmos. Imagine a star moving at incredible speeds, much faster than most of the stars we know. How is it possible for these stars to travel at such speed? What forces propel them to cross intergalactic space so quickly? Since their discovery, these stars have puzzled astronomers. It has been estimated that some of them move at more than 200 kilometers per second. But what could be behind these galactic journeys? One of the most accepted theories suggests that hypervelocity stars are the result of gravitational interactions with other celestial bodies. But how can a simple interaction completely change the trajectory of a star? Let's imagine a binary star system where two stars orbit each other. At a given moment, one of these stars may be violently ejected from the system due to an encounter with another star. This ejection can be so powerful that the hypervelocity star reaches speeds that challenge our understanding of stellar dynamics. But what happens when a star is thrown into space with no home to return to? The search for these stars is not straightforward. Astronomers must carefully observe the sky, looking for those bright lights moving quickly across the vastness of space. However, not all stars that move rapidly are hypervelocity stars. So what is the key to distinguishing them from others? The answer lies in their speed and the history of their formation. What if I told you that some of these stars might have originated in the center of the Milky Way? At the heart of our galaxy, there is a supermassive black hole. This black hole attracts many stars and gas, creating an extremely dynamic environment. Some stars can be thrown outward during intense gravitational interactions. But what about the stars that escape at high speeds in directions opposite to the black hole's pull? Could they be revealing secrets about the formation and evolution of galaxies? An intriguing aspect of hypervelocity stars is that their study offers us clues about dark matter. This invisible component of the universe seems to influence the dynamics of galaxies. So how are hypervelocity stars related to something as elusive as dark matter? By observing how these stars move, scientists can infer the distribution of dark matter in the universe. Isn't it fascinating to think that the way a star moves can reveal information about something we cannot see? Hypervelocity stars are also a reminder of how little we know about the universe. With each discovery, a new wave of questions arises. Are there more hypervelocity stars in other galaxies? Could there be an infinite number of these stars, each with its own unique story? Human curiosity drives us to keep exploring and seeking answers, even when the mysteries seem endless. Moreover, the study of these stars may have implications for the future of astronomy. As we improve our observational technologies, we may be able to detect more hypervelocity stars and understand their role in the structure of the universe. What other secrets could be revealed as we advance in our quest for knowledge? An equally intriguing phenomenon is how these stars can affect their environment. By moving at such high speeds, they may generate shock waves as they interact with the gas and dust they encounter along their path. What happens when a hypervelocity star collides with a cluster of intergalactic matter? It could trigger a series of events that change the way we understand the evolution of galaxies. As we reflect on hypervelocity stars, we also face a dilemma. Are we truly capable of understanding all the phenomena occurring in the universe? Every answer we find opens the door to new questions. How far can we go in our quest to unravel the secrets of the cosmos? Hypervelocity stars are just one chapter in the vast history of the universe. They show us that, although we have made great strides in our understanding, there is still much to discover. Isn't it exciting to think that somewhere in the universe, a star is traveling at an incredible speed, carrying with it the story of its own existence? So, as we continue to look up at the sky, let us remember that each star has its own story to tell. Each flash of light could be a clue about the mysteries that still await resolution. Hypervelocity stars are a reminder that the universe is a place full of surprises, and each discovery brings us a little closer to understanding our own existence in this vast and enigmatic cosmos. In the vast immensity of our solar system, there exists an enigma that has intrigued astronomers and science enthusiasts alike. Is there really a Planet 9? This hypothetical world is said to be located at the far reaches of our solar system, beyond Neptune. But what evidence do we have of its existence? And if it truly exists, what secrets could it reveal about our cosmic history? To understand this mystery, it is important to remember that for a long time, we thought our solar system was composed of the planets we know. However, as telescopes have improved and we have explored beyond the orbits of Neptune, we have found objects that challenge our preconceived ideas. Some of these celestial bodies seem to have a gravitational influence that suggests the presence of an undiscovered planet. But how large would this planet need to be to exert such influence? Theories suggest that this planet could be up to 10 times more massive than Earth, and that its orbit would be extremely elliptical, taking it to the most distant regions of the solar system. But why haven't we been able to see it? The answer may lie in its distance and the faintness of its light. Being so far away, it could be difficult to detect with our current instruments, which are designed to observe closer and brighter objects. But this does not mean there are no traces of its existence. Scientists have been observing the behavior of trans-Neptunian objects, those icy bodies that orbit in the zone beyond Neptune. Some of these objects appear to move in ways that cannot be explained solely by the influence of known planets. This has led to the hypothesis that a giant planet hidden in the darkness of space is pulling on them with its gravity. However, how can we know if there really is a Planet 9, or if we are simply seeing random patterns? One of the most interesting methods that astronomers have used is computer simulation. By modeling the orbits of trans-Neptunian objects, they have been able to see how they would behave under the influence of a massive planet. The simulations suggest that a planet with certain characteristics could be at play, but this is still not definitive proof. So what comes next? For many, the answer lies in the search. With more powerful telescopes and advanced technologies, the possibility of finding this planet becomes an achievable goal. As we continue to explore our solar system, each discovery brings us closer to the truth. How many more surprises await us at the frontiers of our knowledge? The search for Planet 9 is not just about finding a new world. It is also about better understanding how our solar system formed and how its components relate to each other. But what if we never find this planet? The absence of evidence does not necessarily mean it does not exist. Sometimes the mysteries of the universe are deeper than we can imagine. The idea of a hidden planet reminds us that the cosmos is full of surprises and that our understanding is constantly evolving. As science advances, so does our perception of what is possible. Planet 9 could be the key to understanding broader phenomena in our galaxy. Could its existence explain some of the anomalies we have observed in other stellar systems? The possibility that an unknown world is affecting the behavior of other celestial bodies invites us to think about the complexity of the universe. Each new discovery in this field leads us to rethink what we believe we know. As we continue to scrutinize the sky in search of answers, the idea of Planet 9 encourages us to keep an open mind and question our beliefs. Science is ultimately an endless quest for knowledge, and every question we answer opens the door to new uncertainties. The search for this mysterious planet is just one of the many adventures that await us in the vast ocean of space. So what will be the future of our search? As telescopes continue to reveal more of the universe, the intriguing possibility of Planet 9 may become a reality, or perhaps we will face the harsh truth that there are things we still cannot understand. Regardless of the outcome, the journey toward discovery is what truly matters. With each new mission and every new image of the cosmos, we come a little closer to unraveling the mysteries that surround us. Ultimately, the search for Planet 9 teaches us that the universe is a place full of wonders and unanswered questions. It reminds us that every star, every planet, and every galaxy has its own story to tell, and that we, as curious explorers, have the responsibility to listen to those stories. The adventure is just beginning, and the cosmos, with all its secrets, awaits us. The Hubble limit poses one of the most intriguing questions about the universe. Is it really expanding at a constant rate? Since Edwin Hubble made his discovery in 1929, the idea that the universe is moving away from us has revolutionized cosmology. But what does this mean for our understanding of the cosmos? As we delve into this mystery, we find ourselves at the crossroads of astronomy and physics, where answers often lead us to more questions. The expansion of the universe is not just a phenomenon occurring in a vacuum, it is a dynamic process that affects all galaxies. However, what about that Hubble constant, which is used to measure the rate of expansion? In theory, it should be a fixed number, but recent observations show that this rate may be changing. How can this be possible? What cosmic forces are at play? Some scientists suggest that dark energy could be the key to understanding this acceleration. This mysterious form of energy, which makes up about 73% of the universe, seems to drive the expansion. But if dark energy is behind this phenomenon, what exactly is it, and why can't we detect it directly? The lack of clear answers to these questions leaves a void in our understanding of the universe. There are theories proposing that the expansion of the universe may not be uniform. Imagine a balloon inflating. While it seems that all points on its surface are moving away from each other, the speed at which they do so can vary depending on their position on the balloon. So, are there regions of the universe that are expanding faster than others? This could have profound implications for how we understand cosmic structure. Astronomers have measured distances to distant galaxies using supernovae as cosmic beacons. However, the results have been perplexing. Galaxies that should be moving away faster appear to be closer than expected. Is it possible that there is something we do not fully understand about the laws of physics? Or perhaps there are factors we have yet to consider? The evolution of theories about the expansion of the universe has also led to debates about the ultimate fate of everything we know. Some scientists believe that if the expansion continues to accelerate, it could lead to an apocalyptic scenario known as the Big Freeze, where galaxies move so far apart that they become lonely islands in a sea of emptiness. But what happens if the expansion stops or even reverses? Could the universe return to a state of contraction, culminating in a big crunch? One of the most intriguing questions that arises is whether there is a limit to how fast the universe can expand. Could there be a point at which the light from the most distant galaxies becomes unreachable for us? Imagine a future where we can no longer see the stars that were once part of our view of the cosmos. How would this change our perspective on our place in the universe? As technology advances, new tools like space telescopes allow us to look farther and deeper into the universe than ever before. This opens the door to new discoveries, but it also raises the question, what will we do with all this information? Are we prepared to face the truths that may arise from the deepest observations of the cosmos? Data on the expansion of the universe continues to accumulate, and each new observation pushes us to revise our theories. Some scientists suggest that perhaps the current model of cosmology, which includes dark energy and dark matter, needs to be re-evaluated. Could it be that we are at a turning point in our understanding of physics? Are we on the verge of discovering something that will change our view of the universe forever? It is fascinating to think that each new generation of astronomers and physicists may be one step closer to unraveling the secrets of the cosmos. But how far are we really from understanding the true workings of the universe? Are we ready to accept that there are things we may never fully comprehend? The pursuit of knowledge is an endless journey, and each answer brings with it new questions. Reflecting on the Hubble limit, it is clear that the expansion of the universe is not just a physical phenomenon. It is a reminder of our own curiosity and desire to understand the unknown. As future generations continue to explore and question, what other mysteries will the universe reveal? Perhaps the true limit is not Hubble's, but that of our imagination and our capacity to seek answers in the vast cosmos. So, as we look to the stars and ponder the future of our existence, let us remember that each discovery brings us a little closer to the truth, but it also reminds us that the universe has its own secrets. And perhaps there will always be more questions than answers. Human curiosity is infinite, and in this journey toward knowledge, each of us plays a vital role. Ready to keep exploring? What is the ultimate fate of all the matter we know? This question has intrigued scientists and philosophers alike. Throughout history, we have witnessed how matter can transform from one form to another. But what if I told you that, in the end, everything could disintegrate into pure energy? Matter, as we know it, is made up of atoms, and these atoms, in turn, are composed of even smaller particles. In our daily lives, objects seem solid and permanent, but at the subatomic level, everything is a constant ebb and flow of energy. What does this mean for the future of the universe? If matter can break down into energy, is it possible that one day everything we see around us will completely disappear? In modern physics, there is a theory that suggests that as the universe expands, matter will drift apart and disintegrate. This process could be so slow that we would hardly notice it on human timescales, but over billions of years, matter could fade away. Can you imagine an empty universe where there are no stars or planets? Just energy in a chaotic state? Consider also the possibility that, in that distant future, energy itself may transform. Current theories suggest that energy is not eternal. It can change form and ultimately lose its ability to do work. This leads us to wonder, what will happen to the universe when all matter has turned into energy and that energy has been exhausted? In the search for answers, some scientists have speculated about a phenomenon called heat death. This is a state in which the universe reaches thermal equilibrium, where the temperature is uniform. In such a scenario, stars will have burned out and matter will have dispersed to the point where there are no more significant interactions. Is that the final fate that awaits us? But not all news is bleak. Quantum physics offers us a fascinating perspective on the nature of matter and energy. At the quantum level, matter can exhibit characteristics of both particles and waves. This suggests that, even in a state of apparent emptiness, there may be energy fluctuations that challenge our current understanding. Could it be that deep down, everything is always in a state of transformation? Moreover, Einstein's theory of relativity posits that mass and energy are interchangeable. This means that, even if matter disappears, its energy could persist in different forms. Are we then faced with the possibility that the essence of the universe never completely extinguishes but transforms into something entirely different? Black holes are another intriguing element in this conversation. These enormous cosmic structures absorb matter, but what happens to those atoms and particles that fall into them? Some scientists suggest that they could become pure energy, but others wonder if the information about that matter is lost forever, or if, in some way, it can be recovered. Could there be a cycle in which matter transforms and eventually resurfaces? Theories about the multiverse also add a twist to this narrative. If the universe we know comes to an end, could there be another universe where matter and energy follow a different cycle? The idea that our reality is just one of many raises questions about the meaning of existence itself. Is it possible that we may never fully understand the ultimate fate of everything? Meanwhile, research continues. Each year, scientists make new discoveries that challenge our notions about matter, energy, and the universe. What revelations await us in the future? Perhaps, as we advance in our understanding, we will discover that the end of matter is not an end at all, but a new beginning. Ultimately, the fate of matter and energy reflects our own quest for knowledge. Every question we ask brings us a little closer to the truth about the universe. Although the future may be uncertain, human curiosity drives us to explore, inquire, and learn. What other mysteries lie hidden in the vastness of the cosmos, waiting to be discovered? So, while the ultimate fate of matter may seem grim, it is also a reminder of the beauty and complexity of our universe. With each answer we find, new questions arise, and in this endless search, science remains our guide. In this journey, what matters most is not just reaching the answer, but understanding the wonder of the search itself. In the vast and enigmatic universe, there are phenomena that challenge our understanding and leave us with more questions than answers. One of those intriguing mysteries is the so-called axis of evil. But what exactly is it, and why should we care? This enigmatic phenomenon refers to a curious alignment of the cosmic microwave background radiation, which is considered an echo of the Big Bang. Why does the background radiation show a preference for aligning in a specific direction? This is one of the questions that has puzzled astronomers. The cosmic microwave background is like the whisper of the universe, a residual echo of its birth. However, some studies have revealed that this radiation is not evenly distributed. Instead, there seems to be a pattern pointing to certain directions in the sky. Why would this occur? Could it be a mere optical illusion, or is there something deeper at play? One of the most fascinating aspects of the axis of evil is its relationship with the large-scale structure of the universe. By observing how galaxies and galaxy clusters are distributed, scientists have noticed that many of these structures seem to align with this axis. Is it possible that the way galaxies are distributed is influenced by this pattern in cosmic radiation? The idea that the structure of the cosmos is part of a larger design is a difficult concept to accept, but intriguing to explore. Since its discovery, scientists have proposed several theories to explain this strange alignment. Some suggest that it may be the result of gravitational interactions with massive structures such as superclusters of galaxies. Could it then be that these enormous concentrations of matter are influencing the radiation that reaches us from space? However, this hypothesis still leaves many questions unanswered. There is also the possibility that the axis of evil is an indication that there is something beyond what we know in the universe. Some scientists have speculated that it could be a signal of the existence of parallel universes or additional dimensions. Are we glimpsing alternative realities? This idea may sound like science fiction, but in the world of theoretical physics, anything is possible. However, not all scientists are convinced that this alignment is a real phenomenon. Some argue that it could simply be an artifact of our measurement tools and the way we interpret the data. Could it be that we are looking for patterns where none exist? This is a question that invites reflection and debate within the scientific community. Moreover, the controversy surrounding the axis of evil is also fueled by the way observations and analyses have been conducted. The interpretation of data can largely depend on the methods used. Could it be that our understanding is biased by the technology and theories we have at our disposal? This aspect highlights the importance of being critical and open in scientific research. The axis of evil has also attracted media attention, leading to greater public curiosity about the topic. Questions about the origin of the universe, The nature of matter and the possible existence of other worlds are fascinating subjects that spark the imagination. How many more secrets does the cosmos hold that we have yet to discover? The quest for answers continues to be an exciting journey. As scientists continue to investigate this phenomenon, the axis of evil stands as a reminder that there is much we do not understand about the universe. Every answer we find generates new questions, and every mystery solved leads us to new frontiers of knowledge. What other wonders might be hidden in the vastness of space? Science advances through curiosity and questioning. The axis of evil invites us to ponder our own existence and the place we occupy in the cosmos. Are we alone in this vast universe, or are we part of something much larger? These questions are fundamental to our understanding of reality and our role within it. In a way, the mystery of the axis of evil reflects our own search for meaning. As we explore the confines of the universe, we also delve into the deep recesses of our own existence. What do we really know about the cosmos and about ourselves? The answer may be as elusive as the axis of evil itself. In the end, the mystery of the axis of evil reminds us that, although we have made great strides in science and astronomy, the universe remains a place full of surprises and enigmas. Each discovery brings us one step closer to the truth, but also reveals how little we know. Will we be able to unravel the secrets that still lie ahead? The answer is an invitation to keep exploring, to keep questioning, and to never cease marveling at the grandeur of the universe. As we delve into the mysteries of the universe, one question inevitably arises. What do we really know about our place in the cosmos? Throughout history, humanity has looked to the sky, marveling at the stars and seeking answers to questions that seem endless. But are all our answers sufficient? The enigmas we have explored are just the tip of the iceberg. Each discovery leads us to new questions, and each answer seems to open the door to more mysteries. Why is the universe so fascinating? Perhaps because it is a reflection of our own curiosity. Every star, every galaxy, every little corner of space is a reminder that there is so much more beyond what we can see. When we look up at the night sky, we are not just observing bright lights, we are contemplating the vastness of the unknown. What lies beyond what we can observe? Are there civilizations watching us from their distant worlds? The possibility that we are not alone in the universe is both terrifying and exhilarating. The search for answers has led us to develop complex and sometimes contradictory theories. But what if some of these theories are incorrect? How would that affect our understanding of physics and astronomy? Each new discovery has the potential to change the paradigm of what we believe we know. When we think about dark matter, for example, we face a disquieting reality. Much of the universe is made up of something we cannot see or detect directly. What implications does this have for our understanding of the universe and our own existence? The mysteries of the universe also teach us about the nature of time and space. Is time a constant, or are there moments when it distorts? Imagine a universe where time does not flow linearly but folds in on itself. These ideas, while perplexing, invite us to question the reality we consider immutable. Is it possible that time is an illusion and that everything that has happened is occurring simultaneously in a dimension beyond our perception? The pursuit of knowledge never stops. Each generation of scientists and explorers faces the task of unraveling the secrets of the universe. But what happens when the answers we find are not what we expected? History teaches us that often the most important discoveries have emerged from confusion and uncertainty. Perhaps the universe is not a puzzle we must solve, but a journey of continuous exploration. Technological advances have revolutionized our ability to observe the cosmos. How far will we go in our quest for answers? Every telescope we launch into space brings us a little closer to the mysteries that surround us. But as we gather more information, new questions arise. For example, what lies in the darkest corners of the universe that we have yet to observe? Could there be phenomena that challenge all our physical laws? As we reflect on these mysteries, it is crucial to remember that the universe is a vast field of possibilities. Every star that shines in the darkness may host a planetary system, and each of those planets could be home to forms of life we cannot imagine. What surprises does the future hold for us? Human curiosity has been the driving force behind our progress, pushing us to explore the unknown and question what we think we know. The connection between science and philosophy becomes more evident when we consider how the mysteries of the universe affect our perception of existence. What does it mean to be human in such a vast cosmos? The search for answers about our place in the universe often leads us to question our own nature and purpose. Are we here by chance, or is there a design behind our existence? The mysteries of the universe also remind us of our fragility. In a cosmos where the forces of nature can be devastating, what is our role in the grand scheme of things? Reflecting on these topics can be both inspiring and unsettling as we advance in our understanding. It is vital to maintain a sense of humility in the face of the vast unknown. The history of space exploration is filled with bravery and discoveries. Every mission we send into space is a step into the unknown. What legacy will we leave for future generations? Curiosity about the universe is a thread that unites humanity, and each discovery brings us a little closer to understanding our own existence. As we close this chapter on the mysteries of the universe, it is essential to remember that the quest for knowledge never ends. Every answer we find is just the beginning of a new journey. What will be the next great discovery that changes the way we see the world? The only certainty is that as long as we continue to ask questions and explore, the universe will keep revealing its secrets. So what will you do with these questions? Curiosity is the first step toward understanding. Each of us has the capacity to look up at the sky and wonder about what lies beyond. Perhaps in doing so, we will discover not only the mysteries of the universe, but also a little more about ourselves. The adventure of understanding the cosmos is an open invitation, and the next chapter is waiting to be written.